This is the insertion sort algorithm. So again, I'm going to go through this. We want to sort in ascending order. So I have these numbers 7, 4, 10, 8, 3, and 1. These are the position now. The way the insertion sort works is this way. So this is my first index, which is 1 or 0, it doesn't matter. I could have put this to 0, so that's my initial position. Then I'm going to check 4, the second index. See, you compare that, so then you check this condition here. This is my algorithm. Is 4 less than 7? Yes. So I'm going to swap 4 with 7. See? So this is what I have now. I have 8 and 3 and 1. So these are my positions. So in this case, I basically have 10 here, 8, 3, and 1. So the positions are 2, 3, 4. So now, this is where my index is. Next thing to do, check, is 10 less than 7? It's not. Is 10 less than 4? It's not. So it stays as it is. So remember, this was my first pass. Okay? Now, so I have 4, 7, 10, 8, 3, 1. Now, so this is 0, 1, 2. Now I'm going to check 8. Is 8 less than 10? Yes. So swap 8 with 10. So 8 gets swapped with 10. Is 8 less than 8? Less than 7? It's not. So I'm going to leave it as it is. So I 0, 1, 2, 3. So now I have 3 here. So this is my second pass. Now this is where we are. Look at 3. Okay, so that's index 4 and this is index 5. Is 3 less than 10? Yes. So move the 10. Is 3 less than 8? Yes. Move the 8. Is 3 less than 7? Move the 7. Is 3 less than 4? Move the 7. Move the 4, so there's nothing, you insert 3. See, this is, during my third pass, this is what I have now. 0, 1, 2, 3, 4, and 5. That's a 1. So this is where I am. So now, I'm going to go through this one more time. Here's the thing. Is 1 less than 10? So shift 10. 10 goes right there. Okay? Is 1 less than 8? Shift 8 to the right. Is 1 less than 7? Shift 7. Is 1 less than 4? Shift 4. Is 1 less than 3? Shift 3. See, it's going to keep going until it finds a number. Either it's greater than, or if it's less than, it's going to shift. So there's nothing here, it's going to insert. So my fourth pass, okay, so my fourth pass, I have 0, 1, 2, 3, 4, 5. Now, this is the last pass here. So if you look at these numbers, 1, 3, 4, 7, 8, 10, I mean, even if I go through this, there are no swaps here. So these numbers are sorted. So I have a 1, I have a 3, I have a 4, 7, 8, 10. So they are sorted in ascending order. See, ascending order. Okay, so they are actually sorted. Now I could have done the same thing descending, but the whole idea with the insertion sort is that you find the first, you pick which number. So like 7 is less than, if it's less than, you swap it. It's not less than, it stays as it is. So for instance, like we pick 3 here, we're going to keep shifting. 3 is less than 10, and 10, shift 10. 3 is less than 8, shift 8. 3 is less than 7, shift 7. And then 4 is less than 3, so there's nothing to look for anymore, so you insert 3. And remember how we did this. So 1 is the same thing. You keep shifting until you end up with a number, either it's greater than or so, otherwise you do not shift. Now, so I'm done with this. I got my my sorted array or my sorted list. If I look at this, this is my algorithm, so that's why I have two loops. So this is n here and this is n here. So I starts at 0, k is always gonna go 0 minus 1. So I believe, so this has to be a 1. So like I had it before. So because I is 1, so k starts at 0. And then as long as this is true, you keep checking this condition until you find the value for k, and that's the index there. So now, this is n times n, and this is like 1 there. So basically it's a big O of n squared. So it's a sort algorithm where it takes some time to do it. Okay, so this part here, okay, so this is going to be the value for key, and that's what key is. So key goes into this. Okay, so any kind of sorting algorithm, you know, these are one of the most tedious ones. I guess they work for smaller numbers, but once you start getting very, very large number, big O of n squared doesn't really help much. But thank you so much, and thank you for watching the video.